in the genes alone.
Uh-huh.
Um, and then the and then our prescriptions of statins and other what is it? PK9 inhibitor or something like that.
CSK9 inhibitors. Yeah, yeah, yeah. Yeah.
Yeah. Um, so what is what is the mechanism, without trying to go into too much detail, what is the mechanism behind the lowering of our cholesterol? Is it deprivation to a certain degree that our body can't create it?
Yeah, so it depends on which drug you're talking about. You've got PCSK9 inhibitors, you've got HMG-CoA reductase inhibitors, you've got
Mhm.
biosalt sequestrants, you've got many different cholesterol-lowering medications. They all serve the ultimate ulterior motive, really, of getting the cholesterol, particularly your LDL, down.
Hmm.
It's going to somehow interfere with your natural biological processes to produce the cholesterol that the genes deem appropriate to have within the body at any
Right.
given instance in time. The ones that I'm familiar with, for example, HMG-CoA reductase inhibitors, there's an enzyme called HMG-CoA reductase. Anything that ends in ACE, you can immediately assume is an enzyme. So you may have heard of
Okay.
like lactase. That's the
Hmm.
enzyme that breaks apart lactose into glucose and galactose for use, for example. So anything, salivary amylase, you may have heard of that
Right.
before. Yeah, so they're all
Yep.
enzymes. Well, this enzyme specifically is involved in basically, how do I put this to be as broad as possible? It's involved in cholesterol synthesis, but it's through specifically manipulation of one of the primary intermediates in biochemistry,
Hmm.
acetyl-CoA. So you've got acetyl-CoA in the body that is produced through the Krebs cycle, or well, not produced through the Krebs cycle, produced through other pathways like beta oxidation, glycolysis,
Hmm.
and then it enters. It's the primary starting substrate for the Krebs cycle. Basically, it's introduced into the Krebs cycle, but it has many different pathways that it can go through besides the Krebs cycle.
Right.
When it goes through, it can go through another pathway, and it's through it. This is involved in cholesterol synthesis, and one of the primary enzymes in that pathway is HMG-CoA reductase.
Hmm.
HMG-CoA reductase inhibitors do exactly what they say. They inhibit the enzyme. The
They
problem,
inhibit.
yeah, the problem is assuming that if you inhibit an enzyme that's involved in one pathway, that the enzyme itself is only involved in one pathway.